We are going to move on to the prime factors. Prime factors, from what we had before, we referred prime numbers as a number that is that's divisible by 1 and itself. So when you consider a prime number, it is 1 and itself. The division is happening between 1 and itself. Meaning to say, that's the opposite of composite numbers. Remember, we talked about composite numbers in our previous class. So, prime numbers is just 1 in itself. So, the first prime number that we have is 2. All right, as we list our numbers 1, 2, 3, 4, 5, 6, these are natural numbers and so on. 1 is not a prime number because we are saying 1 and itself. 1 is already itself. So we cannot put this one on prime numbers. So the first prime number is 2. All right. Followed by 3. 3 is just 1 and itself. Those are the factors. Factors here is just 1 and what? 1 and 3. 4 is a composite. We cannot take this one. It's a composite. 5, it's a prime number. 1 and 5. 6, that's a composite. 7, it's a prime. So these are prime numbers. So when you are now referring to prime factors, a number is given, but you want to write it as a product of its prime factors. A number given as 12, a composite number, has got factors, which is very true. But of these factors, we want to consider only prime factors, those ones that are divisible by 1 and itself. 1 and itself. Prime, they must be prime numbers. So how do we obtain, or how can we get all the prime numbers? We can use the ladder concept, the ladder diagram, to say that, okay, 12 here, we are going to divide by the prime numbers, starting with the smaller one, all right, is 2 a factor of 12? Yes, it's a factor, and it's a prime number. So you start with 2, divide, so that's 12 divided by 2, all right, which is what? 12 over 2 is 6. So you're going to obtain 6. Whatever that you get, you write it here. 12 divided by 2, it's 6. You move on, so it's like you're having a new number, which is 6. Is there any prime factor, any prime number that you're going to use here for 6? 2 is a prime number, and it's a factor of 6. So we can use that 2 again. Let's divide. By what? By 2. 6 divided by 2, that is what? That is a 3. So 3 is now a new number that you're looking into on its own. Can we say 2 is a factor of 3? No. 3 on its own is a prime number. So the only number that we can use here is 3. So it's 3 divided by 3, which is what? Which is 1. 3 divided by 3 is what? Is 1. We are done. 1, remember, is not a prime number until you get this 1. You cannot say 1, 1, 1, 1. So no. You're done. So the number 12 here, this 12 here, this 12, has been expanded. Has been expanded in prime factors to say 12 can be written as these prime numbers that we have been using, the prime numbers. So the first one is 2 times 2 times 3. So those are the numbers. The answer now. So it's 2 times what? Times 2 times 3. From here, you multiply. So those are the factors, prime factors, not just factors, but prime factors of 12. 2 times 2 times 3. You have written 12 in expanded form of prime numbers. Remember your exponents. You can also write in exponent form. When you say a number, if a number is multiplying itself, a times a times a, 3 times 1, 2, 3. It is same as that to the exponent of 3. A times a times a times a, 4 times a to the exponent of 4. So 2 times 2 is multiplying itself what? 2 times. So it can be written in exponent form as 2 to the exponent of 2 times what? Times 3. This is referred to as the exponent form. Exponent form. It's still as a product of its prime factors, but only that it is what? It is in exponent what? In exponent form. So this is how you can express any number as a product of what? Of its prime factors. You consider the prime numbers, those that are divisible by what? 1 and itself, starting from 2, 2, 3, and so on in that order. All right, let's consider, this part is direct. Let us just consider one or two. We want to express these numbers as product of their prime factors. So express 50 as a product, of its prime factors. Okay, so using the ladder concept or the ladder diagram, we're going to start with the smallest prime number, which is 2, 3, and so on and so on. So we try 2. Is 2 a factor of 50? Yes, it is a prime factor of 50. 50 divided by 2, so you can even use a calculator if you do not understand. 50 divided by 2 is what? 25. So you have 25 here. This is the new number that you have now. So you try again. Is 2 a factor? No, cannot work. Let's try 25 divided by 2. This cannot work. You are getting a fraction. 25 divided by 3. This cannot work. You are getting a fraction. You move on to 5. 25 divided by 5. You are getting a whole number there. So meaning to say the next, the factor for 25, which is a prime number, is going to be what? Is going to be 5. So 5. 25 divided by 5 is what? Is 5. 5 is a new number and 5 is a prime number. So when 5 is a prime number as it is, you are going to use as it is 5 into 5, which is what? Which is 1. So this is it. The number 50 can be written, this 50 here, can be written as what? 2 times 5 times 5. 2 times 5 times 5. Just like that. In exponent form, you can write as 2 times, here 5 times 5, it is multiplying itself 2 times. 2 times. So that's 5 to the exponent of 2. Just like that. This is in exponent form. Exponent form. Here we just expressed as a product of its prime factors, just in a normal way or a normal format. So guys, you see, it's just a basic. Just know your prime numbers. You're done. Just know your prime numbers. All right, let's try another one. Express this time. Let us use 216 as a product of its prime factors. So just like what we had, I want you to try this one, then check the answers after. All right, so, okay, I think you are done. 216. Ladder diagram. So let's start. The first prime number is what? Is 2. So is 2 a factor of this? We can try. Calculator is there. 216 divided by 2. We get 108. So truly it is a factor. 2 is a factor because you are getting what? a whole number there. So meaning to say we can use 2. That's the smallest. 216 divided by 2, we saw that we obtained what? 108. That's a new number that you're having at all. You start again from the smallest 2. You try 108 divided by 2. 108 divided by 2. And we can see that we are getting a whole number. So 2 is a factor and it's a prime number there. So we can use 2. So that's 2. 108 divided by 2 gave us what? It gave us 54. Just like that. 54 is a new number, so you treat it on its own. You start again from these prime numbers. The smallest is 2. So you divide and check if it is going to give us what? A whole number. 54 divided by 2, exactly. So 2 is what? A factor of 54. And 54 divided by 2 is what? 27. You start again. 27 is a new number. So can we use 2 this time? All right, let's try. 27 divided by 2 gives us a fraction or a decimal. So this one is not a factor. It is giving us a remainder in that. So 2 is out. You move on to 3. You try 27 divided by 3, which is 9. So it means 3 is a factor of what? 27. So 27 divided by 3 is 9. Just like that. But if you know, you find out with time, guys, you'll be knowing these, guys. You'll be knowing these. There will be no need of a calculator to do this. So you move on to 9, you can see 9, 2 is not a factor of 9. So you move on to 3. 9 divided by 3 is 3. So 3 is a what? 3 is a factor of 9. 9 divided by 3 is what? Is 3. So 3 is a prime number. There is no need for you to use any 2. You just go straight to that 3 because it's a what? It's a prime number. So that's 3 here. 3 divided by 3 is what? Is 1. So this is it. This is what you're going to have from 216. Guys, 216 can be written as 2 times 2 times 2. 3 times. 2 times 2 times 2 is 3 times 3 times 3 times 3 times 3 times 3. So this here can also be written as 2 is multiplying itself how many times? 3 times 2 to the exponent of 3 times 3 is multiplying itself how many times? 3 times 3 to the exponent of 3. The number of times. Just like that. Just like that. So you see, guys, it's all about revision. Just like that. No matter how big the value is. All right. Then another way, using the calculator, let me explain this one again. You can simply use the calculator for you to attempt this question, all right? Before I move on to the next question, using a calculator. So you can verify using a calculator. On your calculator, there is this part here, which is the fact button. Sorry for that. The fact here, this one, fact, the one with this dot, the dot, comma, that one. All right. So if you check on that one, the fact, in order for you to access this fact, you must have shift. You see this brown thing, shift. It's also shift. So we must have what? Shift to access that. So it's shift. Then we need what? Fact, which is the one that is under those 3. So that is like this. 216 is equal to, you press equal to, all right? First, you write your number, then press equal to, all right? So you must see it here. You must see it here. Yeah, this one. 216, all right? Then after that, you press this now, shift then fact. Why am I writing theft? Now it's like theft. It's fact. So it's shift on your calculator. Shift. You must see the S on your calculator there to represent shift. So that's you press these dots here on this fact. You press it. So it's going to give you the answer. 2 to the exponent of 3 times 3 to the exponent of 3. It is already giving you the answer in the simplest form. So you can have your answer direct from the calculator. Okay? Just like that. Okay, let's try another one. Sorry for that. Let's try 50. So what did I say? 50 is equal to. That's the first thing. 50 is equal to. Then shift fact 2 times 5 to the power of 2. So this is 2 times 5 to the power of 2. Exactly the same answer that we got from what we had. We also had 12. Let's do that one. So 12 is equal to, then shift fact 2 to the exponent of 2 times what? 3. So 12 is 2 to the exponent of 2 times 3. You can use your calculator direct, but using the ladder diagram, you must know what you're dealing with. So here it is just for a proof. You can use your calculator as a proof. All right. Just gonna, all right, let's try this one. We're gonna use a calculator and also use the ladder diagram. All right. Express 1125 as a product of its prime factors. If we are going to use a calculator, it was direct. You're just going to take this 1125 is equal to, then shift fact 3 to the exponent of 2 times 5 to the exponent of 3. So we want to see if exactly we are going to have this 3 to the exponent of 2 times 5 to the exponent of 3. All right, using the ladder diagram. All right, let's solve. Let's simplify, So this is 1125. Prime factors, prime numbers, 2. Can 2 be used? 2 cannot work, guys. 5. So 2 is totally out. You move on to 3. So you can try that. Okay, 1125 divided by 2, as you can see, is totally out. So let's move on to 3. 1125 divided by 3. We are getting a whole number that's a factor. So 3 is a prime factor of this. So you can use 3. So if we divide 1125 divided by 3, we obtained what? 375. So that's 375. There's a 5 here, guys, so never try a 2. Try 3. So let's try 3. 375 divided by 3, exact. So we're going to use 3. So if we divide by 3, we're going to get what? 125. We try again 3 and see 125 divided by 3. So as you can see, it does not work. So you move on to 5. If 3 does not work, you move on to 5. So 125 divided by 5. We are getting what? An exact value. So 5 is what? A factor. So that's 5. 125 divided by 5 is what? 25. So we move on. 25, 3 cannot work, 2 cannot work, so 5 there. So 25 divided by 5 is 5. 5 is a prime number, so we're just going to use 5 here. 5 divided by 5 is what? Is 1. So this is it. As we can see, as a product of its prime factors, 1125 is equal to what? 3 times 3. 3 times 3. 5 times 5 times 5. 5 times 5 times what? Times 5. Which is exactly as this one, only that the format is exponent form. 3 times 3, 3 to the exponent of 2. 5 times 5 times 5, 5 to the exponent of 3. It is just about the format. The last one is the exponent what? The exponent form, which is exactly what we got from our calculator. 1125 is equal to, then shift fact, just like that. Same answer. So you can use a calculator as for verification, just like that. All right. So let's try last one. All right. I want you to try this one. Then we are done for this class. We will be done. So join membership so that you do not miss any of the other classes that we are going to have. Make sure that you join membership. All right, the last one, 900. All right, let's start with the calculator. 900 is equal to, then shift fact. So this is our answer that we are having. All right, so we are going to obtain something like 2 to the exponent of 2, 3 to the exponent of 2, 5 to the exponent of 2. All right, no problem. So let's use the ladder diagram to try and simplify it. So 900, the smallest prime number being 2, we can see there's a 0 there, so 2 is going to work. So 900 divided by 2 is what? 450. All right, let's use our calculator. Divide by 2, that is what? 450. Again, divide by 2, as we have got a 0 there, it's going to work. So 450 divided by 2 is 225. If we are to divide by 2, we are going to obtain 225. So where there is a 5, never try to use a 2. Where there's a 5, you can try 3 there. So let's try 3. 225 divided by 3. This is what? 75. So this is going to work. So that's divide by 3 gave us 75. There's a 5. So we try 3. 75 divided by 3 gives us 25. So 3 is a factor. 75 divided by 3 gave us what? 25. 25, 3 cannot work. So we move on to 5. 25 divided by 5, that is 5. All right. 5 is a prime number, so 5 divided by 5 here is what? Is 1. So this is what we have. 900 can be written as 2 times 2. All right, then 3 times what? Times 3 times 3. Then 5 and 5. 5 times what? Times 5, which is exactly this way in exponent form. It is exactly what we had before in what? In exponent what? In exponent form. So this is how these questions can be given as. You just have to try as many questions as you can. Revision is the way out. So that's 2 times 2, 2 to the exponent of 2. 3 times 3, 3 to the exponent of 2. 5 times 5, 5 to the exponent of 2 in exponent form. Revision. Let's revise. All right. So we shall see as we move on, revisions, working with question papers as well, so that you understand how are they going to be asking these questions. You need to understand. So revision is important. Mathematics is all about what? Practice. Do as many questions as you can till we meet again.